We're back for video lesson number 25. Today's lesson is on independent probability. For this lesson, you will need the notes you were given in class, a pencil or pen to take notes, of course a highlighter, marker, or colored pencil to highlight keywords, and calculators are permitted for this whole unit. All right, so for the past few days, we have focused on compound probability, simple probability, which is one event. And your SOL is actually focuses on compound probability, which is two or more events. So let's jump right into the notes. Compound probability or independent events. For compound probability, we're going to give you a formula to determine the likelihood or chance of two separate events occurring at the same time. And these events are going to be classified either as independent or dependent. So the first definition we're going to do is independent events, and we'll focus on, in the next video lesson, we'll focus on dependent events. So today's lesson is on the independent events, and these are events in which the result of the first event does not affect the result of a second event. So with all compound probability, of course, you're going to be doing one thing and then following it up with a second one. The key word here, and you'll want to highlight it, is with replacement. So this is things like Susie selecting 2 chips from a bag of red and blue chips. What is the probability of her selecting one chip and replacing it before she selects a second chip? So since she's putting it back in the bag, the number that's in the bag didn't change, so it's independent. Some other things that are always independent are spinning a spinner and flipping a coin and rolling dice. You don't have to worry about the words with replacement there because those are understood to be independent. Rolling a dice, the first roll never affects the second roll. And likewise with flipping a coin. I can flip it twice and the first flip has nothing to do with the second flip. The only time that it's going to affect it is if you're taking an amount out, and so there's fewer in the bag when you go to take the second one out, and that would be your dependent. So independent probability, here's a further explanation with some pictures. It is when an item is replaced so that it doesn't change the total possible outcomes, and this is what makes it independent. So for example, if I take a soccer ball out of a box, but then I put it back in, there's still the same number in the box as when I started. So it's an independent event. And I already said this, but I'm going to say it again, that anytime you have spinners or you're rolling dice, these are always independent because each spin is independent of the next one. It's not like I'm taking sections off the spinner. And let's jump into how you calculate compound probability. So when we were doing simple probability, it was just one fraction. And to calculate compound probability, you find the probability or likelihood for each event. And then, so each one's going to have its own fraction, and then you multiply the fractions together. Don't forget to simplify. And with these, some of these numbers get pretty big, so you may want to cross simplify or simplify before you multiply just so your numbers aren't quite so big. So let's look at our first example. What is the probability of flipping heads on a coin and then rolling 5 on a dice? So with flipping heads on a coin, you've got 2 options. You've got heads and you've got tails. And they're saying flipping heads, which is 1 out of 2. And then rolling 5 on a dice. Of course, we've done this during our simple probability section. If you're rolling 5 on a dice, there's 1 5 out of 6. And then, of course, we're going to multiply these together. And this is independent because they're 2 separate objects that have nothing to do with each other. So anytime you have 2 different things like flipping a coin, rolling dice, or spinning a spinner, rolling dice, or drawing something out of a bag and rolling dice, they're two separate things. They have nothing to do with one another. That is always independent. Okay, so back to what we have. We have the probability of heads, which is 1/2, times the probability of a 5 on a dice, which is 1/6. And when I multiply them, multiply your numerators, that's the top number, first. 1 times 1 is just 1, and then 2 times 6 is 12. And this I can't simplify any further, so I'm done. So in example number 2, we have a spinner, and it's labeled red, blue, green, and yellow. And they want to know what's the probability of spinning a green and then a blue. So we have a green, and there's 1 out of 4, so its fraction is 1/4. And then spinning a blue is also 1 out of 4, and we multiply those two fractions together, and we get 1 times 1 is 1, 4 times 4 is 16, and our final answer is 1/16 because I cannot simplify it any further. But what would I do if I was asked what is the probability of spinning 2 reds in a row? Remember, every time you spin a spinner, it's an independent event, so it doesn't affect the second one. So it's like doing the same simple probability twice. So what is the probability of 1 red? Is 1/4, and then of the second red is also 1/4, and then we just multiply it. So technically, what is the probability of getting a green and a blue has the same probability as spinning 2 reds. Doesn't seem like it should be like that, but mathematically they are the exact same because each spin is independent. And here's our last examples. So, and you'll see this similar kind of questions on your test, on your SOL. So we have a drawer, and it contains 8 white socks and 4 gray socks. As we said before, that you use probability every day, including when you go to pick out your clothing. So we all have different colored socks. If we have 8 white socks and 4 gray socks, I put a picture below, that means that we have a total of 12 socks in our drawer. And they're saying what is the probability of picking a white sock? So if we look at our first example, we have 8 white socks out of 12, which is our total. So 8 is our numerator, that's our favorable outcomes. 12 is our total outcomes, and so our fraction is 8/12. Now, it says that I'm going to replace it. So I pick it out of the drawer, I decide I don't want to wear it, and I put it back. And then they want to know what's the probability of picking a gray sock. Well, there are 4 gray socks because I put the other sock back. We still have 12 socks in my drawer. Now, I'm going to go ahead and multiply this across just like I would, if I didn't simplify. 8 times 4 is 32, and 12 times 12 is 144. So these numbers, like I said, are going to get really big really fast, and if you don't know your math facts, it's going to be harder to simplify. On the second example, I'll show you how you can simplify first before you multiply to keep your numbers smaller. For 32 over 144, I'm going to try dividing by 4 because I know both of them can be divided by 4, and I end up getting 8 over 36. But I can still divide these both by 4. So I'm going to divide by 4 again, and I end up getting 2 over 9. So my final answer on this is 2/9. I could have simplified the 4/12 first and the 8/12 before I multiplied, and I could have gotten smaller numbers and had less simplifying to do later on. Okay, look at the last example on your page. It says a drawer contains 8 white socks and 4 gray socks. Same problem. What is the probability of picking 2 gray socks with replacement? Meaning I pick a gray sock, decide I don't want to wear that sock, put it back in my drawer, and then pick another gray sock. So, first example, there are 4 gray socks. That's my favorables out of the 12 total socks. Remember, even though I'm trying to pick gray, the white ones are still in my drawer, so that makes the 12. And then if I put my gray sock that I chose back, I'm going to try to draw again. I still have 4 gray socks out of 12. And this time, before I multiply, I'm going to simplify. 4/12, I can divide both of those by 4 and I end up with 1/3. Same thing on the second example, I can divide both of them by 4 and I get 1/3 again. Then I'm multiplying 1/3 times 1/3 and I end up with 1/9. That was much easier than trying to simplify multiple times like I had to do in the first example. All right, before you log out and go and do your homework quiz, I want you to go ahead and put a triangle in the bottom left corner of your paper. Put a triangle in the bottom left corner of your paper, and then you can show me what you know. Log in and do your homework quiz.